Hello, everybody. Hope you guys are doing well. So, before we continue, um, just let me check if uh, let me check the stream if it's working as it is supposed to. Oh no, what is this? Yeah, yeah. Just let me check if the screen is in sync. And okay, it is 9, 6. Yeah, this is annoying from Twitch, but can't help it. It's good. Okay, okay. So our stream is up and running. Let's have a window and let's get this thing here. Okay, so today we would be starting with application layer. We have already dealt with what do you say, data link layer, but then I decided to change the flow, and so today we would be going with um application layer. So let's say application. Now this layer is very the meaning itself is, or like the word itself is very indicative, right? So this is how our or this is at the application. That means this is how our application will make um or how our application will be able to access the internet, right? So right now we were only dealing with computers, right? And then we were saying that those how those computers are interacting. So now we have come at the application. Now this application can be any program, right? It can be anything. For example, it can be as simple as a web browser. For example, web browser. Then it can be a mobile app. Then it can be, for example, YouTube, right? Again, a streaming service. So what it does is basically um, you are watching videos on the net, right? But nowadays an offline version is also available, but that is not the discussion right now. So basically these are all applications, right? I mean, I'm at the so application is basically where we would be writing our code, and then to host this on the internet or to perform certain things, we would be using the application, right? So basically, for example, if you're trying to make an API call, right? This is basically you are trying to connect to another computer, right? Which where the API is basically going to fetch you and give you the data. So this is a very common thing. And so this is by application I'm meaning to say is right. So previously those layers are hidden, right? For example, this is the most practical layer that you can see, right? Even if you write a web server in any language, the first thing that we do is you will try to make an request, right? So that is why so we are at that layer. This layer can be physically seen in the computer, right? The rest other layers, for example, our transport layer or network layer, one cannot see those layers, right? Those layers are present, but they are not able to user cannot see them. But this is where you can get the look and feel of internet, right? Now, the application layer enables the user, whether human or software, to access the network, right? It provides interfaces and support such as electronic mail, file access transfer, access to systems resources, surfing the World Wide Web, and network management. Now, the application is responsible for providing services to the user, right? So that's what it's trying to say. Basically, what it's trying to say is this is basically where the application will enable us to access the network, right? Now, it provides all the services and the interfaces that we needed for suppose for example file access transfer, now access to system resources, surfing the world web, etc. Now remember, the physical layer is this is the first layer, right? I mean, okay, if you are at the center side, then this is going to be your first layer, right? Where you are going to this layer is present at the top of the OSI model, right? So here is where is the application layer is being present. Now the application is responsible for providing service to the user. So now we will discuss some applications that are designed as client server pair, and then what happens when the client sends a request for a service to the server, and what does the server respond, right? Additional other protocols at this level or at the application layer is DNS, right? The process DNS is that thing that is going to do our what is say word to number mapping, right? Ultimately computers can only understand numbers, right? So then we would be studying that as well. One more application is basically remote login, electronic mail, and file transfer, right? So how you can remotely log in and access a system. Then this electronic mail, right? For example, you have SMTP, you have Outlook. How those applications are working. And then again you have file transfer, right? How you can use the internet to have file transfer. Okay, so the first, and then we are going to study in more details the World Wide Web or WWW. We will study in detail what is the HTTP, what are the different types of HTTP 1, 2, 3, and why one was a bad one, 2 was little bit improved, and 3 is the latest one. So we will try to see all of that. Now then we will see SNMP, right? Simple mail protocol, how is that working? And then we will try to discuss different multimedia and other another other requests. The domain name service. So this is the first what do you say? This is the first domain name system. Now so there are several applications in the application layer, right? That follows the client server paradigm. So basically here we are dealing with the client server thing, right? We are saying that the client sends and request to the server and the server. So this is a very famous architecture. So basically most our applications are based on this paradigm, that a client will this is my client, and then it will send so this is a very famous model, right? It is called as the client server model. So basically the client sends a request to the server, and then the server will respond back, will send in the response. So this is nothing but this is my client, this is my server. So this is nothing but called as the client server architecture or the client server model. Now so we will have various applications running, right? So at the application level you may have different applications that follow this paradigm, right? Wherein the client is requesting data for server. So you may have different applications that may follow this paradigm, or you may have certain applications that may not follow this paradigm as well. So first thing that we are going to study is only for those applications that are going to follow this what do you say, this client server architecture, or basically the applications that are running based on this model, which is a client and a server. Now, the first thing that we are going to study is a domain name server, right? So, domain, this is very common, right? Recently, there was a lot of controversy, right? Someone bought uh, the domain name of Geo before it would, before it was going to merge with Geo Hotstar, right? So, what is this domain name? Why do we need it? We'll see all that. Okay, now let us see how does a domain name, like what is the job, right? I mean, why do we have this domain name server in the first place, and what is this its role? Okay, so for example, whenever you send a request, right? I mean, so for example, suppose you have a mail server, right? And the figure shows how an example of a DNS client-server program can support on the email to find the IP address of an email, right? A user of an email program may know the email address of the recipient. However, the IP needs the IP address. The DNS manages. So the job of this DNS is basically to convert the name into a number, right? That it is basically working as a mapper, which is going to map the names to the numbers. So I mean, the first is like we are trying to understand why do we have a domain name, like why should we have a domain name? What is this domain name system? Why it is so important for us to understand? So users, when you use, right, you cannot understand numbers, right? Humans, for example, tldraw.com. Now this is not a number, right? This is a name. So basically what it's happening here is we are we instead of typing in numbers, we are providing we are providing a name which is more easy to search for the user, and using this name the user can obtain the actual address, right? So what do you mean by domain? So now domain is like a specialized field, right? I mean, whether it is um yeah, big. So basically what that domain name server is going to do, it is going to map this number to something called as an IP address, right? Because everything is number, right? Eventually it is going to be eventually. So what is an IP address? So let's assume, so basically when we say a client and a server, these two are basically a computer, right? So a computer can a computer will communicate when only it has the address of this other computer, right? So that address is nothing but in computer systems all address are in the form of numbers, right? That too there is a specific format for that number, right? So that number is nothing but called as the IP address, right? So basically we need the IP address of this computer, and then only we will be able to access this. But remember, it is very difficult for a user to it's very bad for as a user interface, right? When you write a number, like when you write, it is very difficult for the users to remember numbers, right? So there are so many different sites, right? So assume each site is basically like a physical computer where the IP address of that computer is mapped to to a name. And so basically these names are not available, right? You have to buy it from some web hosting services, like for example GoDaddy is one of that, right? So you go and buy and map your IP address to that number. For humans, it is very easy to have this name written, right? Instead of typing the actual IP address of the computer, it is easy to for us to have this. But remember, when we want to send a request to this computer, uh, if we are going to access to this computer, or we are going to touch down this computer, for the computer, this tl.com is garbage, right? It won't be able to understand because it can only understand numbers. So that is why we do a domain name to number mapping, right? So basically the job of the domain name system is basically to map an IP address with the specific domain name, right? Now let's like there are certain intercases as well, right? So let's see. um Now these are remember, not all the problem is with this number, right? The problem is that these numbers are not these names are not available, right? uh, this is an issue, right? So we need to buy this name. Now this name also has certain specific areas, or it has certain specific, it is a very, it is written in a very specific format, right? That format is something that we need to study, or that format is nothing but in the form of an hierarchy. So now the problem is, why do we need to like we are trying to understand. So the first thing that we understood is we need something that needs to do a mapping of names to so this is the first thing that we need, right? The next thing that we want is basically something called as, the next thing that I'm trying to understand is, so why are so these names have to be unique, right? And there is a specific format of writing these names, because now why do we need to pay for this DNS, or why do we need to pay for the domain name? Like, why do we? The next thing that we are trying to understand is, so there are certain companies that make these names available, right? So now let's see what happens. Now there is what do you say? Um, so now these domain name servers are uh, what do you say, are owned by certain companies, right? So you will have a domain. Um, so next topic that we are trying to understand is, why do we need to pay? So our goal is basically to identify the need to pay for domain name, because it's ultimately, if it's a name, right? I mean, so basically um like, why do we need to, can we not use our Can we not generate a new name and then just generate a unique name and then just use it? Now we are going to understand that why do we need to pay for the domain name. Now so these domain names will be managed by some company, right? Because these names, we need to make sure that we need to ensure that the names are unique and no two domains can match, right? Because just imagine in that situation, then we will get IP address of like two so basically the thing which is going to resolve or going to do the mapping will get confused, right? So first thing that we need to ensure is that the names are unique. And so the easiest way to do is it's like registering your you can consider this as you buying your own house and adding your nameplate, right? So when you buy that, so when you it is similar in that line. So in that sense, when you buy a property or something, the first thing that you do is you assign or you take the property papers, right? For example, you're going to sign the property papers, and then you're going to mention that who are the first holders of that specific property, who are the second holders, and so on and so other rules, right? On similar lines, so that paper is basically making that unique identification, right? We need to pay for that paper, right? For us, that is basically called as stamp duty, right? So whenever you buy a house, you first do the registration of that property in your name, right? So that no other person can come and use it, and that whole property is something managed by a realtor, right? On similar lines, now there are certain companies that are responsible for managing these names, right? For example, so certain companies like GoDaddy, and then one of you have Namecheap, and then you have Google Domains. Basically, these are companies that are responsible for uh, uh, doing the registration, right? So basically, what it is going to make sure is that that name is first of all it's specific of you, and the way this is written is a format, right? So it will charge you based on this format, and it will do the IP mapping, right? And it will basically try to prevent the misuse, right? Because what happens is sometimes what people do is, for example, if they come to know something is going to be some companies are going to merge, right? So when they do the merging, everything has to change, right? The website name is no longer what they had originally, right? So then the name appearing here should be set so that even if a common person is able to write it and search it, and then he should be able to do the mapping of its name to its server. So you basically need a domain name, right? So the job of this companies are basically to maintain or to maintain domain skirting, right? For example, what you do is, if you come to know that two companies are all going to get merged, or you have an inclination, so what you do is you buy that name, and once that name has been registered, remember, no one can take it, right? Same like a property. Once the property has been registered in your name, until unless the other person pays money for it, you cannot the other person cannot claim its what you say claim the like it cannot claim that that property is right, cannot be the cannot claim is he's owning that property, right? So until he buys it, so what people do is, people kind of take this advantage, and then they come to know they buy these domains, and then they try selling it at a very higher price to the company, right? The next thing that additional services. So now these are and not only this, these also provide additional services, right? So the for example, one of the additional services is a DNS management, then is private protection, then the email hosting, and then one more important thing is basically SSL certificates, right? So these are basically the additional function that is done by this domain name server. Now, why is it not free? If it's free, then the problem thing is, if it's free, then what will happen is, first of all, there would everyone will complain, right? And anyone would be able to like buy and manage, so there won't be any uniqueness left, right? For example, if you buy something and tomorrow I come and claim that it is mine, so you need to do some sort of registration or some sort of book you need to maintain, right? And remember, there are thousands of websites, right? So that job is basically taken care by this GoDaddy, so that tomorrow no other person comes and once you own that domain name, no other person can come and search your or no other person can claim that it is their property. Now uh, so now there is a way this domain name structure has been designed, right? Okay, so now when the internet was small, mapping was done by using a host file, right? The host file, so when it was small, it is very, when initially during when it was ARPANET, you did not have many websites, right? So you only had you had limited computers, right? So at that time, you did not need this system, right? What you could do is you could maintain a ledger, or basically a record that contain a ledger is like a record of financial transactions. On similar lines, you maintain a ledger or a record where you have every address mapped and the name being written, right? But however, today it is impossible to have a single file, right? Because there are so many names available. So then this is a problem, right? To host that file to store would be very cumbersome, right? And when we want to access that size, we need to make a search in that site. So that is not a very good solution, right? So basically, so that is not a very good way of having that name registry being kept. The other way is basically, what you do is, the other disadvantage of having that is, just imagine the number of people are going to the number of people that are going to request to access to that file, and then provide the search in that file for the name to IP is going to be used, right? When you have more number of people accessing that, then it kind of becomes a difficult, right? So the solution that we do is, or the solution that we use is, basically what we divide this is we divide this huge information into smaller parts, and then we store it on different computers, right? So in this way, the mapping that needs can contact the closest computer holding the needed information. So this is nothing but how domain name system works, or how domain name management is going to happen is, basically we are going to so in this we'll see how DNS works, and then we'll describe the protocol itself. Now namespace. Now there are certain terminologies that we are going to understand here. So namespace is basically name assigned machines must be carefully selected from the namespace without complete control over the binding between the names and IP, right? In other words, what we are trying to say is that each address has to map to a unique name, and we can that can be done in two ways. Either you have a flat structure or a hierarchical structure. A flat namespace in flat namespace, a name is assigned to an address. Now, name in this space is a sequence of character with structure, right? They may or may not have a common section. If they do, they have the disadvantage of using a flat name is that it cannot be used on large systems as the internet because it must be centrally stored to avoid ambiguity and replication, right? So instead, what he's trying to say is, what if you only have, why is the need to have this this tail draw, right? Why do we have, oh no, okay, yeah, the link has opened, I don't know. Yeah, so why, what I'm trying to understand is, why do we have why don't we have like a flat name, right? For example, mine and yours names like a flat name, right? Why don't we have a flat name? For example, like Steve, this is again a name, right? And then what if you have some other person called as Fred, and then you have one more person called as Alex. So this is basically a flat name, right? Now the problem in this approach is, um, all of these names have to be stored on a single file, right? So that is one big problem. Now then what we do is, the other way is, instead of having a single name, what we do is we kind of have an, we maintain an hierarchy of names, right? So we have an hierarchy of names over here. Now what basically what is going to happen is, for example, the example is, or let's say this tl dot, so let's say this tl mm, tl.com, right? Now this is not a single flat name, right? So basically this has 2 to 3 parts, right? So first part is basically this tl draw, then you have a dot, and then you have a com right at the end. So this is basically what we are going to do, is the first part. um, yeah, so basically what we have done is, instead of having a central single name, we are kind of achieving little bit of decentralization, right? So that instead of storing it on in a central authority, you can form that name. Now the first part will define the nature of the organization, the second part will define the name of the organization, and the third part will define the departments, right? So that is more easier and uh, more efficient way of decentralizing, right? The central authority can assign the parts that the name defines the nature of the organization and the name of the organization. The responsibility of the names can be given to organization itself. The organization can add, you can add suffix, prefix, whatever you want to do. So we will see that. So now we said that our domain namespace is basically an hierarchy, right? Basically a tree-like structure which has a root at the top, right? Now the tree can have only 128 levels. So level 0 is the root. We have level 127. Now, okay, now let's see how our hierarchical name is present. Now, uh, now label. Now each tree has a label, right? Which is the string with the maximum of 63 characters. The root is an empty string. Now the DNS requires that the child of a node have different labels, which guarantees the uniqueness. So basically, it is like a hierarchy-like structure. Okay, and every node will have a unique name. Now let's see how is that name given, right? Like how is that name going to be found? Okay, so the when we will form that domain name, it will be the ending. It will be from the bottom to the top, and the ending will always be a null character. For example, let's see. For example, we will have something called as berkeley.edu, right? So berkeley.edu is a domain name, right? So you have berkeley.e dot edu. So this is one domain name, right? Now the way this named is formed is from the bottom to the top. So remember, this is going to be at the top of the tree, and this is at the bottom of the tree. Okay. Now to have an hierarchical namespace, a domain name is designed. Now in this design, the names are defined. So basically, we have like a tree-like structure, right? So you have one. This is my root node. I have different branches, and each node is nothing but a label. A label is basically to identify or to arrange a text. Now the maximum character this label can be is of you can have 63 characters maximum that can be possible, right? Now DNS requires that the children of a node that branch from the same node have different labels, which guarantees. Now how are we guaranteeing uniqueness is so basically, if you are branching from this specific node, then so if you are at this specific node, then it will branch to a different name. So this is how that uniqueness is going to be maintained. Now, a full domain name is a sequence of labels separated by dots. The domain names are always read from the node up from. So the way I'm going to be reading is from year to year, not from the top to the bottom. The last character is always going to be a null string. Okay. Now if I terminate, now there are two. So you can, based on how they are terminated, you have two possible domains, right? So generally, either it will be a full what do you say, a fully qualified domain name. So fully qualified domain name. So basically, this will end with the dot. Contains the name of a full name of a host. It contains all the labels from the most specific to the most general. And it will be ending with the dot. For example, challenger.a.tbda.edu. Now, for example, the domain name is the FDF full qualified domain name. Challenger installed at Advanced Technology Center. Now, DNS server can only match a fully qualified domain name to an address. Not that the name must end with the null, because the null means nothing. We use a dot. The partially qualified domain name. The partially qualified domain name starts from a node but does not reach the root. It is used when the name to be resolved belongs to the same site as the client. Here, the resolver can supply a missing part called the suffix to create a fully qualified domain name. For example, if a user at JHDU site wants to get an IP of the challenger computer, he or she can define the partial name challenger. The DS client will add the suffix etc.ghd.edu before passing the address to the DNS. So basically, the client holds. Okay, so this is wait. There is some. So further, you can classify domain names into two types. One is when you have one is a fully qualified domain name, another is a partially qualified domain name. So let's spend more time here. So what's the why do we use this um fully qualified domain name? Like, what's the advantage of having a fully qualified domain name? Okay, so an F fully qualified domain name is the exact or the absolute address. For example, www dot okay. For example, www dot google.com. That is the actual or the exact name. So, for example, this is one example is this. So you can say this is one example of a fully qualified. Oh, what happened? This is a fully control Z. Did it based on yeah. Let's add text and then let's add the arrow here. So this is a fully qualified domain name. This is basically directly mapping the name to the address. There is no ambiguity. Now these are basically used to identify servers, devices, and services. Now FQDNs are required for SSL, TSL certificates to secure. We'll see what is that SSL and TLS. We haven't gotten that far. Now then we have something called as PQDN, right? So we have something called as partially so we have partially qualified domain names. No, it's okay if you partially qualified domain name. No, partially qualified is not fully specified in the DNS hierarchy. For example, okay. Mm, I mean, what's the advantage of having a PQDN? Because ultimately, you need the fully qualified name, right? So is this how? Mm, okay. Now let's see. What is the advantage of having a PQD? Like, I mean, we only need one, right? Uh, okay, so now this is where we are typing entirely, right? So basically we are mentioning three parts. So this is we are giving the exact. So we are saying this is first, second, and third, right? So what we do is now remember you sometimes you cannot even remember this string, right? You will like to have a partially name being written, right? So what you will do is basically you instead of typing the entire full name, you kind of use a pqdn, and then based on certain process it will identify the. So basically it is enabling more help, right? Remember, the user is a very lazy person, right? He doesn't have time to remember the numbers. So then we came to a complaint. We needed the name, right, or the full name to number mapping. This is nothing but my fully qualified domain name. But then remember, even the user won't is so lazy that he won't type such a big text, right? Instead, you will always type a partially qualified domain name. So um, it is basically uh, it is basically further to enhance user or to limit the user from typing everything. Yeah, this is basically what we are uh, the system will basically append the remaining thing. So ideally you would need to convert this to a fully qualified domain name, but then there are certain other mechanisms which is going to do that distribution. And one more thing that we said is okay, yeah. So basically we have a hierarchy instead of a flat name because we said like finding a name through a huge unsorted list is difficult, right? However, finding in an hierarchy is more easyable and it will require less amount of time, right? Because we know the roots are. Now a domain is a subtree of a domain namespace. So now let's see what we are talking about domain. A domain is a subtree of the domain namespace. The name of the domain is the domain name of the node at the top of the subtree. What is it trying to say? So for example, um now hierarchy of name server. So this is how where we so basically how are we giving to a domain name, right? So the topmost is basically the root server, right? The topmost is my is going to be my root server name. So I'm going to have root server here. Then the at the next is basically now the solution to these problems is to distribute hierarchy of name servers. So there is an issue, right? Uh so I said what is the problem? Okay, so now there is one more issue, right? So basically so what if we have flat names, like there is no domain name or nothing? First draw disadvantages is no, like control C. So the first disadvantage is basically um so like what if these are multiple computers that want to access, right? So what should ideally will happen is they will all first uh, call to the hierarchy, right? I mean they will for all first If there is no okay, there is okay, yeah. So if there is no no hierarchy, right? So what these are different devices, right? And we need to access different websites. So basically, what we need to do here we need to maintain a central repository that has all the names, right? So just imagine the amount of traffic that is going to. What if there are more than one computer requesting for the same resource? So you can just imagine how many people are requesting at a time for the same. For example, google.com, right? It gives the results in just like point 0.00002 seconds, right? So if we have that IP name to address mapping being mentioned here, and if it's like a central name point, then everything is going to be messed up, right? It will take thousand like so much time for us just to access. Not only that, if this is a central point of failure, right? If anything goes wrong in this, everyone loses the access. So instead of having that, what we do is we kind of distribute the information among many computers called as DNS servers. So one is to divide the whole space into many domains based on first level. In other words, we let the root stand alone and create as many domains. Uh, the first thing that is we are not going to have a single file storing everything. So what we are going to do is we are going to have an hierarchy of name servers. Now, what a server is responsible for as the authority over is called a zone. Now we define a zone. If a server accepts the responsibility over a domain and does not divide the domain into smaller domains, what are we trying to say here is uh, hierarchy. Now we have introduced a term called as server, right? So let's study why are we saying it a server. Or even if this would be a database, then it will be far too slow, right? So what we do is okay. So yeah, that is just okay, and then No, there is something. This is a name server. This is very specific thing which he has mentioned. Just let me check this. Okay, so what we are doing is instead of storing it in a single file, we are distributing we are distributing that the entire name and into different levels, and each level in a tree like structure like a node, and each node basically has um some sort of registry which basically contains what to say a domain name for that. Is that what is going to happen? Okay, so we have a .com server that is working. Oh yeah, so the job of Okay, so basically, what we are going to do is we are going to have different, instead of having this central database or this central repository, what we are going to do is we are going to have different computers running, and each computer has the job of each computer is basically to determine whether the domain is located within the hierarchy. So the root, uh, for example, the moment first it goes to the root. The root is a server. It will then check, and it will perform some computing, and it will check like which computer or which server should it direct to. For example, a .com, a .org, or so that the request will be transferred to .com to that specific node, and that in that node I'll have the specific yeah, the specific name, right? So then I'll go and resolve that name to the IP. Is that what is going to happen? Then the next question that I want to ask is, will the .com, is it containing of everything in there, like all anything that ends with .com? Notice there is something called as an authoritative DNS server. Notice this. Now, after I come to a top level domain server, okay, then I pass it to the authority that is actually hold the domain DNS records. So if you query, it's the DNS that is going to come. Oh, I see. Now, who owns this? Like, who owns the .com? Who is owning them? Okay, so there is a company called as VeriSign. Okay, and then there is, okay, there is ICANN that is responsible for the .com. So where does GoDaddy come into picture? Also, GoDaddy is nothing but an intermediary, or it's the realtor, okay, which is, yeah, ultimately that registration is of the government, right? You're going to go and register it to the government. So the realtor is like, it's like the middleman, or the person that is going to say that specific, um okay. So let's say, because if that is holding. Oh, okay, okay. Okay, so that .com is owned by some company, right? And Google is basically that name that I have given. Okay, so I mean, let's take an example of Google itself, right? So that we can understand. So first, the resolution is coming to this .com. So we say that we need to go to the .com. It's an hierarchy. It will have different. It wouldn't be a single flat name, right? It will be like separated by different dots. And then what we will do is, now, so each dot has a specific purpose. So the middle one is indicating the name, I guess. So this is basically, like which top level directory am I going to? Is it an edu? Is it at .in .ca? So I'm going to that registry, and then I'm putting in the name, right? Now, we directly cannot access these companies like to the .com or the end or whatever you want. So there is an intermediary which is present, which is GoDaddy or any other company which is responsible to do this, and they may take some fees, or like some hosting fee or brokerage fee from us. So basically, and then we have, there is a mechanism in which that resolution is going to perform. So that is something that is that is uh, that is when you have already registered and you want to do the calling of that domain name, right? So I don't want that. I need to understand, like, why do we, so the okay, you have this hierarchy. First is basically, instead of having a single flat name, you kind of form that. Okay, so basically the job of that hierarchy is to form that name, so that instead of having a single large file, we are going to have different elements, and then based on that the resolution is, so this is going to be like virtually it is going to be formed in the computer, something like that, which is going to happen. uh, Just give me 1 minute. Okay, so hence instead of having a like a single name, like, so this is all been developed before, right? They knew that this problem would occur. So just imagine number of what if, like, if you have a central file. I mean, there is a reason for us to have like our domain name in this format. There is a specific reason, and that reason is basically to avoid this central database, right? We don't want, this is a very bad or a poor choice. Oh, so this is a good choice. I mean, this central thing is something that we don't want, right? We don't want this central name to be present, or a directly flat name to be present. Instead, we kind of want to form it in a tree like format, so that there is no central point of failure. Although the failure can occur at these top level domains, right? Because here is wherein the search is going to start. But then again, these companies have certain mechanisms. Uh, okay, certain mechanisms for which um to avoid that central point of failure. Now, why is it called as domain? Domain basically, domain meaning in English, like, I mean, I did say domain, but then okay, yeah, so these are basically specific um like these are specific areas, right? For example, the doc.com will be here, so it's like very basically it's an area of so I have done, so people say, right, they are doing a research in this specific domain. So then on similar lines we say that our website is like .com domain or some other domain. Like, does domain, Yeah, basically it's having that unique piece of so yeah, the job of that domain, or in other words, was basically to have that unique identification, right? For example, in electronics domain or in computer systems domain, so you're giving that unique identification. Oh, so that is why it is called as domain. Okay, yeah. So I guess this is all for domain name system. Like, we just studied why we needed domain. We haven't studied how we are going to resolve the number to name mapping. So we'll see that in the next lecture. Till that, take care. Bye bye.